Okay, hi everyone. My name is Serra-Willow Buchanan. I'm a postdoc at the University of Guelph working with Dr. Adam Gillespie. This is, actually you can introduce yourself.
My name is Devon Beckman. I'm a master's candidate, also working with Dr. Adam Gillespie.
Perfect. So we're going to be giving you an update on our project, Organic Matter Building with Biomass Crops. Unfortunately, we're not going to be sharing any results because we're kind of in the middle of processing all of our data, but we will be giving an update on where we're at, what we're doing, and kind of the overall purpose of the project. There are many collaborators that have been a part of this project that we want to acknowledge, including our summer students. You may notice one name, Devon Beckman, who is an undergrad on this project and loved it so much he decided to become a master's student, as well as our funding partners in both Ontario and Quebec. So it's nice to talk to a group of people who clearly know what biomass crops are, so I don't have to go over that. But one of the benefits we see them having is that they're able to build these really deep root systems. So by pulling carbon dioxide out of the air, fixing it into their biomass, they're not only doing that with above ground biomass, but they're putting it into their below ground biomass as well. And this gives us a great opportunity to have carbon sequestered or returned to the soil into deeper layers of the soil. Now, one of the things that we're not completely sure of, we know that biomass crops have the potential to sequester carbon, but we're really wondering how this is going to change or how this potential is going to change. One, between switchgrass varieties, different cultivars. For this project, we're focusing mostly on Caven Rock, Big Rock, and Sundance, which is that Caven Rock Blue Jacket hybrid. We do have cultivars of miscanthus as well that we'll be looking at, as well as a couple other varieties of switchgrass, but these are the three that we had really nice replication within our fields for, so it's kind of what we're focusing on. We also want to know how this is going to change between soil textures, because we know that carbon storage is going to be very different under a high sand versus a high clay soil. So we're assessing this ability for carbon sequestration under these different soil textural types. And then finally, we're looking at geographic regions, again, having plots here in Ontario, as well as within Quebec. So the overall purpose of the project then is to quantify the carbon being sequestered by switchgrass stands in Ontario and Quebec. Again, thinking about these differences in cultivars, differences between soil types, and differences between geographic regions. And what we're looking at is not just total carbon that's being stored in the soil. We're really interested in looking at specifics about this carbon. One being looking at particulate organic matter versus mineral absorbed organic matter, which Devon will speak a little bit more about. These are different fractions within the soil. We're also interested in looking at the actual contribution of the plant itself to this carbon. I'll be talking about this and our process of looking at this using stable carbon isotopes. And as well, we want to know what the stability of that carbon is. How resistant is it to degradation within the soil? So overall, we are hoping that the results of this study will be able to demonstrate the value of planting this crop in terms of its ability to remediate soil and provide environmental benefits like stable carbon within the soil. So what do we expect to happen? Well, we expect that biomass crops will sequester more than annual crops. This is something that's been kind of proven in other studies as we've looked at other literature. We also expect that soil carbon accumulation will extend to deeper layers over time. So we expect, because of these deep rooting systems, that we're going to see more carbon stored deeper that's given directly by the plant. And we also believe that carbon derived from biomass crops are going to be more stable. So when we look at the stability of the carbon in those deep layers, and we look at the amount of carbon derived from the biomass crop, we expect to see a correlation between those. I'm now going to throw it over to Devon, who's going to tell you a little bit of our sampling sites and methods. There you go.
So if you're looking at our sites right here, we have multiple within Ontario and Quebec. I'm sure a lot of you recognize the Ontario sites. In Quebec, we kind of stayed along the St. Lawrence, looking at different latitudes. So our sampling procedure, we took 1 meter deep soil cores. We took 3 of these per plot to get a couple replicates. So we used a modified post planter. We had a couple issues with that breaking. But so what this does is it allows us to essentially capture a meter deep soil profile. Like essentially photograph of the different layers. So this is our methodology. If you look here at the top, we sampled different varieties and controls. Just for this graphic, I used a fallow field, but we did grass anyways, forested areas, and cash crops for our controls. We took the soil cores and we divided them into 4 different depths. We went 0 to 15, 15 to 30 centimeters, 36 centimeters, 60 to 100 centimeters. Essentially, we're trying to look at the deeper depths and see if we're sequestering more carbon in these greater depths due to the greater rooting depth of the biomass crops. We then took these samples, dragged them, and sieved them through a 250 micron sieve, and this essentially gives us particulate organic matter and mineral associated organic matter. So the particle associated stuff is going to be more your sand sized particles. It's going to be less plant available and needs to be broken down further. The mineral associated organic matter is going to be what crops can take up and use to build their structures. And then we further are going to, in the future, we're going to use combustion analysis machine to analyze these for the carbon percentage and the nitrogen percentage. And we'll take these values and run them through a PROC mixed statistical test, which will allow us to compare the different varieties to controls and see if there's any significant results.
All right, so for my part of the project, I'm really interested in this idea of how much of this carbon is actually being allocated from the plant itself. This can be through root exudation, root decomposition, microbial biomass. And so we're going to be using natural abundant stable carbon isotopes to try to figure this out. Essentially, switchgrass is a C4 plant. It uses the less heavy form of carbon within the atmosphere. So isotopically, it has a less negative isotopic signature ranging from about -16 to -10. Whereas when we look at soils that have had C3 plants, which are a lot of our varieties of agricultural crops, excluding corn, which is a C4, which is giving us a little bit of a problem finding sites. But it uses, it doesn't discriminate as much against the heaviness of carbon. So it has an isotopic signature or around -33 to -24. So by looking at the difference between these two, we can try to figure out how much carbon is actually coming from the plant itself. Just as Devon said, we're using these same cores, the same samples, we're subsampling on the same ones. So I'll be looking at the same depth segments, looking at the allocation of carbon, again, at that 0 to 15, 15 to 30, 30 to 60, and 60 to 100 to see where we're actually having carbon allocation happening. And again, if you remember, we're really looking at this and asking the question, are there differences between varietal types? Are there differences between soil textural types? And are there geographic regional differences? The other thing that we really want to assess is the stability of the carbon. So stability referring to how resistant that carbon is to decomposition. And to do this, we're using programmed pyrolysis. So this is where you burn the carbon at a very high temperature, and where half of that carbon burns is where we would consider, so if half of that carbon burns at a higher temperature, we would consider it more stable. It took more heat, more energy to actually decompose it. Whereas if it burned at a less high temperature, it would be a less stable or more labile form of carbon. So once again, we're doing this within those depth segments and asking that question of, is there a difference between cultivars, soil types, and geographic regions? Now, as I said, we don't have any data for you yet because we're in the process of getting all of this together. But so far, we have completed our sample collection. This was done in the summer of 2023 and 2024. We might have a bit more collection this summer. We will see. We have also subsampled, air dried, and sieved all of the cores. So we've taken them, broken them down into those depth segments, left them out to air dry, and put them through a sieve. And then we've also taken a subsample for soil grinding so that we can do some chemical analysis. So in the process is our POM and MAM content. This is the part that Devon is currently working on, which is taking a very long time. We also have total carbon and nitrogen that we're analyzing these for. I'm about more than halfway done analyzing all these samples, so we should have that done very soon. And once that is done, we will be sending our samples to the University of Saskatchewan for stable isotope analysis. And we will also be sending them out for pyrolysis. We're just awaiting a contract and an actual price for the company to give us. Soil textural analysis is another thing that we want to do on these soils. And I anticipate that this will be done sometime in the summer where we have some undergraduate help on this. Soil textural analysis will be done with a hydrometer method, so it does take quite a bit of time to go through each of our samples. And then finally, we'll be going over and statistically analyzing the data. So next year when we're here, we'll hopefully have some good results that we'll be able to present to you. All right, if you think that this is a project that you'd be interested in, if you have any questions that you think would be, that we could answer with the data that we currently have, feel free to reach out to Adam Gillespie. His email is up here. And thank you very much.